Welcome to today's episode of Drop the Knowledge by Citaloop. I'm your host, Daniela Fonseca, and I am excited to bring you a deep dive into one of the most innovative projects happening in Europe's green industrial transformation, the Citaloop project. Today, we are gladly joined by a representative from Beckham, Patrick Deggan. He is the head of innovation management at Beckham and also a key partner in the Citaloop project. So today, he will talk about the benefits of Citaloop for lubricant developers, the PFAS alternatives use case. Dear Patrick, thank you so much for joining us. To kick things off, could you please introduce yourself and tell our listeners about your role at Beckham and how is your involvement with Citaloop?
Hello, Daniela. Thank you for the invitation and the opportunity to introduce myself and Beckham. As you mentioned, my name is Patrick Degen. I'm the head of the innovation management at Beckham. And in this position, I'm responsible for the supervising and coordination of funded projects, for example, like Citaloop. And in the Citaloop project, Beckham has an advisory role in many different sub-projects. And we are also responsible for one of the three use cases. This is the replacement of PFAS-containing solid lubricants in greases or other kind of lubricants.
That's great. Thank you so much. But let's start with the basics because in the beginning, when I was talking about the title of our podcast, I introduced an acronym that might be unfamiliar to some people. And you mentioned it again when you said that you would be responsible in Citaloop for the replacement of PFAS. Could you briefly explain what PFAS are and why they have historically been used in lubricants?
Yeah, sure. PFAS stands for pair and polyfluorinated alkylenic substances. So it's a group of very stable fluorine-containing chemicals. And they are known for being extremely resistant to heat and chemicals or oxidation. And it's precisely these properties that have made them attractive for lubricants in the past. They are used in particular widespread where other additives would fail, for example, in high temperature applications or in processes, for example, at vacuum in aerospace industry or on demanding mechanical engineering applications.
That's a great start. Out of curiosity, dear Patrick, you said that their use was particularly widespread, and I asked you why they were historically been used in lubricants, but PFAS can be found in other products that we use in our daily lives, right?
Yeah, that's right. They are more or less common in many, many applications. For example, the anti-stick pants, for example, the coatings on pants are made from PFAS.
Okay, that just to have an idea. As you were saying, given their widespread use, what are the current environmental and health concerns that are associated with these compounds that have led to the increase in regulation, particularly here in the European Union?
Yeah, as I said, PFAS are extremely stable substances, and exactly what makes them so useful in lubricants and in other industrial applications. But unfortunately, this stability also means that they hardly degrade in the environment. And this is a problem because you get exceeded concentrations over the time. And due to this persistence and potential of bioaccumulation, the European Chemical Agency, the ECHA, has identified PFAS as substances of very high concern. And this leading to proposed restrictions across various sectors and also included restrictions in lubricants.
That's a great explanation. What specifically triggered the industry towards finding these PFAS-free alternatives? It's their bioaccumulation, the fact that they persist in the environment. Was it purely regulatory pressure, or were there other catalysts?
Of course, regulation plays a major role. Many PFAS are on banned lists in the European Union, but companies like Beckham themselves also want to take responsibility to protect the environment. And at the same time, more and more customers are asking for safe and sustainable alternatives, for example, in food industry, medical technology, or automotive industry. And all these different factors together have accelerated the change process.
Yes, it makes sense, of course. And when you said that the regulatory um, pressure is a major role, it makes all the sense, not only for the environment, but for our health as well, right? The accumulation. As we explore these alternatives, the PFAS alternatives, what are the most promising options that we have either currently available or that are under the development in the market, of course, for the lubricants?
There are some promising PFAS-free options both in the market and in the development right now. These include, for example, synthetic esters or silicon oils as alternative for PFPE oils that can withstand high temperatures and have demanding tribological requirements. Innovative polymer-based additives as alternatives for PTFE that delivered similar lubricating and non-stick properties to PTFE is a second example. But overall, I think the trend is clearly moving towards a combination of performances, safety, and sustainability.
Of course, of course. And when you're saying that we are moving towards a combination of performance, one of the first things that comes to mind is the fact that it's important that these products can withstand high temperatures, but you need to circumvent bioaccumulation and, if possible, recyclability, right?
Yeah, that's right.
Okay.
And
Yeah, go ahead.
yeah,
Go ahead.
it's a combination of different properties which are really important to handle.
Oh, that's great to hear. How do these alternatives truly compare in terms of performance? And I'm thinking about these crucial properties for lubricants because we need to think about thermal stability, right? Friction reduction, and maybe other tribological characteristics. In a straight swap, is it a straight swap or are there trade-offs when we compare with the other alternatives?
So PFAS alternatives at the moment are getting closer and closer to the performance of traditional PFAS solutions. But a one-to-one replacement is rarely possible without compromises. As I mentioned, you have the chemical stability, the temperature stability, the low friction coefficient, and all these different properties are really hard to challenge by one-to-one replacement. But for example, some synthetic esters or polymer additives offer very good thermal stability and really good friction reduction, but do not come close to chemical resistance to PFAS. So in short, it is often only possible to replace individual aspects of the PFAS properties with one single alternative.
There's still then a long way to go, or at least there's room for improvement in here. And are there specific challenges when reformulating products to exclude PFAS while still maintaining that high level of performance that industries demand?
Yes, the reformulation without PFAS is a real challenge. As I mentioned, you can't replace it one to one, so you need many different alternatives to fulfill all the requirements. And PFAS simply have unique properties, so it's not so easy. When replacing them, you often have to combine several new additives to achieve the same performance that the single PFAS substance have. And then there are tests under real conditions to ensure that the lubricants work reliable, even under high temperatures, high pressure, as I mentioned, or aggressive media. And it is therefore not a simple replacement, but a complex development process in which performance, stability, and environmental compatibility must be carefully balanced, and the testing process is really, really hard and time consuming.
Yes, I imagine, because as you were saying, if it's almost impossible to do a one-to-one replacement, then you have to test several solutions or formulations, let's call it like that, right? And you have to test the addition of new additives or new compounds, and then try and test for the performance, and the time-consuming part. It's a bit exhausting, and it's part of the developing process, but it's one of the things that along the development phase is more time-consuming, right?
Yeah, that's right. And if you think about automotive applications, the testing procedures take so much time because often it's a safety issue in the car. And so you have really, really hard testing procedures to test it
Ensure.
completely new substances or lubricants.
Yes, and that makes sense to test everything, and particularly to make sure that regarding safety, you are achieving the same performance while making sure they are safe. You mentioned the EU regulations earlier. How the regulations that we have in place in the EU specifically influence the strategy to move away from PFAS in lubricants? And what is the impact that they have on the pace of innovation?
So I think the EU regulations of PFAS are one of the strongest drivers in the last centuries, and it's a strong driver for the switch to PFAS-free lubricants. And I think this EU regulation is one of the examples where you see the strongest impact for the development of new alternatives, or to develop new substances overall. And the EU regulations set clear limits on which substances may and may not be used, and create clear pressure for the manufacturers and the end users to act and to handle and to find alternatives. And this has two effects. Firstly, for the manufacturers, it accelerates the research and development of new and safety alternatives really strong. And secondly, it ensures that the companies implement sustainable solutions at an early stage. This is important for our end users. So they have the pressure to implement these new technologies really fast. And both have really strong influence on the pace of this new alternative in the lubricating industry.
Yes, absolutely. And it makes all the sense. Even though we do not see it directly, there are so many areas that work and depend on lubricants, and there's so many development that is running backstage to accelerate the development of these alternatives that comply with regulation, that it actually we might see novel products in the market, but as we were saying before, it's a bit time consuming, but at the same time, it's a new step to move towards a more sustainable and eco-friendly solution. Looking at the market, if we take a look at the market, how can PFAS-free lubricants, if they become a reality soon, serve as a competitive advantage for companies, especially in the context of green procurement and the fact that we are witnessing an increase of consumers that are more environmentally conscious?
I think, as I described before, the EU regulation has such a strong impact and pressure to the end users and to the manufacturers that in the moment, I think the PFAS-free lubricants are a real competitive advantage, because everyone asks us, everyone has the pressure to change their lubricating system, their automotive industry, mechanical components, and so on. And I think more and more customers want environmentally friendly products, by ourselves, by themselves, or by regulations and so on. And companies that opt this for PFAS-free solutions at the early stage show that they take responsibility and are innovative, and this is definitely a competitive advantage.
Yes, yes, and make sure, right, when the companies sell themselves their products or services, also based on what is part of their system. So if they consume responsibly, they also send the message that they are eco-friendly, responsible, and innovative as well, and being at the forefront of the sustainability and development. It's something that catches easily our eyes and sparks attention, because the market actually has room for improvement in this. Dear Patrick, considering the long-term landscape, what are the implications of this transition from the PFAS lubricants, or for the lubricants that include PFAS, to the ones that are free? And the practical question as part of this, as part of the long-term implications, do you think that the PFAS-free lubricants are going to be generally more expensive to produce or acquire?
So two questions. The first one, in the long term, I think PFAS in lubricants will be largely replaced by alternatives and will only continue to be needed for some special applications. For example, space applications where you have satellites in the orbit. Then you have low pressure, you have high radiation. For such kind of applications, I think PFAS will be still needed, but for all the rest, I think in the future we have alternatives. And the second question, in practical terms, PFAS-free lubricants are often more expensive to develop and to manufacture. As I described, you need not only one additive, you have to replace the PFAS by three different alternatives. But the raw material costs to be necessarily have not to be more expensive. So I think at the end, the lubricants are not more expensive than the others.
Yes, I was asking that because of the development phase, that sometimes if it's longer, we always, or at least consumers tend to assume that the final product might be more expensive. One extra question, dear Patrick. When we are talking about the development of lubricants and PFAS-free lubricants, is recyclability something that also is on the table, talking about recyclability of lubricants and how to gather the components and to make sure that we can use them for other purposes, or at least to make sure that there is a proper way to dispose them without being a burden to the environment?
Yeah, sure. This is overall, besides the PFAS problematic, another one hot topic for the lubricating industry. How can we recycle our products? How can we get for example, the mineral oil in some lubricants? How can we recycle it and reuse it again? And my opinion is, if we find alternatives for PFAS, we also make the recycling process more easier, because the recycling of PFAS components is really hard and tricky.
Can you elaborate a little bit on the
Sorry?
recyclability? Could you elaborate a little on the tricky part of recycling, in particular, PFAS lubricants?
Yeah, okay. So if you think about PTFE as one of the solid PFAS, also containing one of the PFAS materials which is solid and works as a solid lubricant, this is, yeah, you can't melt it. It's thermal resistant, as I described. It's chemical resistant, so you can't dilute it in a liquid, in solid,
Yeah.
whatever, or in any kind of liquid. And if you heat it up to over the melting temperature, you chemically destroyed it, so it's not really
Okay.
meltable. So yeah, I think it's not possible in the easy way to reuse it again.
Oh, that's great. Then when we think about the eco the eco-friendly part of the PFAS-free lubricants, on sustainability, recyclability. There's so much that we can look into. That the fact that the lubricants were developed with PFAS their development was mainly focused on their performance, right? And now we are taking a look a little bit further, and now this is why people like you, Patrick, are working towards the development of the use cases in which you replace PFAS. Patrick, this has been an incredibly insightful discussion, and I really enjoyed talking a little bit about the future of the lubricant industry with you. I believe there's so much more to share. But thank you so much for sharing your expertise with us today.
Thank you very much. I'm delighted. It's an interesting and exciting topic that affects the entire industry, not only the lubricating industry. And I'm pleased to have been able to provide some insights in this problematic from the developer point of view. And in my opinion, the switch to PFAS-free solutions is a great opportunity for the environment, sure, but also for the industry like Bechem.
Yes, absolutely. And I believe that our listeners will learn a little bit more from this podcast. So thank you again, dear Patrick. And thanks also to our listeners for tuning into our podcast, Drop the Knowledge. Join us for our next time for more deep dives into the world of groundbreaking innovation as part of the CITALoop project. See you.